go. So circle trig 3, this is dealing with inverse trig functions. We've already kind of dealt with the inverse trig functions a little bit. Let's see if you can remember this. This is a recall sort of situation. Let's say I write that expression right there, or equation, sine of theta equals 1/2. We talked about how theta is our input, right? What sort of thing is theta? I'm looking for the word angle. Someone said it. Yeah, it's an angle. What sort of thing is the 1/2? It's a ratio. Originally, we understood it to be the ratio of the opposite side of the triangle over the hypotenuse, but now we are more aware that we can write it as what over what? The y value over the r value. More specifically, we would say if you have a terminal point, or if you have a point on the terminal side of that particular angle, then it's going to be the y value of that terminal point divided by the distance from the origin to that point. That's what the y and the r mean. Okay. All right, well, that's pretty good. So sine with a little -1 right here of 1/2 equals theta. We kind of did this before when we were doing with right triangle trig and we wanted to find the angle, right? It was inverse sine, and here our input is the ratio, and our output is what? The angle. I think we first discussed this when I talked about like the enemies. So we had an enemies discussion, like kind of these little comic book examples, sort of like for every addition there's a subtraction, like arch enemy, and for every multiplication there's division. For every sign there's an inverse sign. Okay, that's what we would say. Inverse sign. That's how we would say the whole thing. Notice inverse sign does not mean 1 over sine. It's not the reciprocal. Okay? What it means is the reverse process. It means I'm going to give you a ratio and you're going to tell me the angle. Okay? Now I know that's confusing because once again, as we mentioned before, if I have 5 to the -1, what does 5 to the -1 mean, class? It does mean 1 over 5. But with functions, that's not what it means. Just deal with it. Okay? That fact that you've got like exponents up here, like sort of like superscripts with the negative exponents, or negative, it really caused mathematicians that wanted to be programmers and kind of be able to have computers understand all this stuff. It really gave them fits because sometimes you have a -1 there and it means negative exponent, sometimes it means inverse, and it's like, how do I know which one you're referring to? And we know because we're like, oh, that's sine, but the computer doesn't know. So they had some fun figuring all that stuff out. There's some interesting things that we can deal with sine and inverse sine. It kind of is like if I take 2 steps forward, class, and then I take 2 steps backward. Where am I? From where I started from, right? So let's say I have x, and I add 5 to x. But then I subtract 5 from that answer. Where am I, class? I'm at x. Famous calculus movie called, can't remember the name, Stand and Deliver, where this math teacher goes into an inner city Los Angeles school and starts teaching the remedial math students, and then he teaches them all the way up to calculus. They all do awesome with the calculus test. But he starts off with them. There's a part where he says, minus 2 plus 2. What is it? You ever go to the beach? Minus 2 plus 2. Fill the hole. Dig a hole. The hole is the negative. Anyway, so I look at this minus 5 plus 5, and it reminds me of that part of that famous movie. Maybe we'll watch it sometime. We'll do it every day. I don't know. What about this? X squared. And then I take the square root. Where am I? I'm back at x. So what about this? What if I had 45 degrees and I took the sine of that? Okay, so now I've got some ratio, right? Some y over r. But then on that answer, I took the inverse sine of it. I said, you've got that ratio. Tell me what angle it was. Where am I at, class? 45. Okay, so that's kind of, you can have inverse sine inside of a sine. So that's kind of neat. Got to relate something else though to here, so just kind of keep all of that in mind. I'm not sure what that's all about. Oh yeah, okay, I do need to talk about that. All right, here's some stuff. We'll write a question down here. What sort of numbers am I going to get from sines and cosines? I should get ratios. How big ratios? Okay, mostly numbers over 1, right? So remember that sine is y over r, right? And cosine is x over r. If I'm dealing with the unit circle, right? Then I'm going to have, like, that's my y and that's my x over 1. What is the biggest possible y value that I could have? What's the biggest possible, Robert, what's the biggest y value I could have if I'm going around that unit circle? 1. The biggest y value is up there when I'm at 1, right? So the biggest ratio that I would have would be 1 over 1. Does that make sense? Which 1 over 1 is 1. What's the smallest y value that I could have?
Like absolute value? Or
No, it's like most negative value. Negative 1. My y value could be all the way down here. And if that's the case, I'd be at negative 1 over 1, which is negative 1. So all these other values, if my y value is here or here or here or here, no matter what angle I happen to be at, okay? Notice this value, this y value right here is less than 1. This y value is less than 1. This y value is less than 1. This y value, it's all between those two. All right, what does that mean? Okay, here my y values are between negative 1 and positive 1. So for instance, I'm going to have something like negative 1 over 1. I could have like negative 0.9 over 1, negative 0.5 over 1. I could have 0.5 over 1. I could have 0.866 over 1. I could have 1 over 1. That's pretty much the whole range of values. Wouldn't y'all agree? The lowest value that I could have is negative 1. So negative 1, negative 0.9, negative 0.5, 0, 0.5, 0.866. Are y'all getting that? It's the y values I'm allowed. This value, this value, this value, this value, all the way, or those are the only y values that I'm allowed. So, what's negative 1 over 1, class? Negative 1. Negative 0.9 over 1. Negative 0.9. Negative 0.5 over 1. Negative 0.5. Negative or 0.5 over 1. 0.866 over 1. 1 over 1. 1. Okay? These are my allowed sign values. So it looks to me like sine is kind of limited. If I do sine of theta, I'm going to get a number between -1 and +1. Let's put your calculator in degree mode and test that out. So what we're saying right now, what I'm telling you is that sine theta is always going to be less than or equal to 1 or greater than or equal to -1. So let's just do sine of 100. Make sure you're in degree mode.
0.98.
Let's do sine of 200. Sine of 500.
0.61.
Sine of 360.
0.
Okay, yeah. Anybody try a few more numbers up there. See, can you get a sine bigger than 1? I'm gonna wait for anybody. Or smaller than -1, or more negative, that is. Any luck? Is everybody getting like 0.99 or 0.5 or 0.8 or 0.3, something like that? Yeah. That's kind of an interesting thing. It's not something we've really talked about. Sine of theta is always going to give you a number between -1 and +1. Although, let's be honest here, those of you that can think like this, follow along with me real quick. Which is bigger, class, Y or R? Y. Okay. On a triangle, which side is going to be the biggest? Hypotenuse. So you have the biggest over something smaller. If you have something small over the biggest number, it's all, at most you could have the same thing over itself, right? But everything else, it's going to be a fraction. It's going to be less than 1. Okay? And if that's the case, what about x values? What's the biggest x value that I can have on the unit circle? 1.
Yeah.
What's the smallest value that I can have? Or the most negative value that I can have? -1. And for that same reasoning, cosine, the x value is always going to be less than the r value. All right? So my cosine has the same sort of situation. Cosine is always going to be between +1 and -1. I'm going to jump ahead a little bit. When we eventually, in a few weeks, look at the graph, we're going to notice that sine and cosine both stay between -1 and +1. They kind of look sinusoidal, they look like a wave, which is why Trig is so awesome in dealing with waves and simulating those kind of things. Okay? Keep this fact in mind, because tomorrow when we pick this up, we're going to find out how this relates to inverse sine and inverse cosine. Okay? I think we're pretty much in class. All right. Circle trig 1, 2, and 3 are all due this Friday, along with your 10 topics. All right? Have a good day.
And our quiz.